All right, so the first one we did, negative 1.28 and positive 1.28. And then the middle 90%, the middle 90%, the two edges, this one's kind of in between. It's in between negative 1.64 and negative 1.65. Either one of them's okay. Either one of them. Oops. Is okay. As long as you use the same one on each side, it's okay. Like you could use 1.64 or 1.65. It's okay because they're the same distance away. And then middle 95 means there are 2.5% in each. 2.5% in each. So that one is 1.96. So negative 1.96 and positive 1.96. Middle 98 means there's 1% in each tail. So 1%. The closest one, I think, is negative 2.33. Positive 2.33. And then the last one, middle 99%, means there's a 0.5% in each tail. 0.5% in the green. So if there's a 0.5%, it's going to be the closest one that'll fall between negative 2.57 and negative 2.58. So either one's okay. Negative 2.57 or negative 2.58, as long as you use the same one on each side. Okay? So what you guys found was called critical values. Those are critical values that we're going to be using for confidence intervals. Okay? So let's fill out our table here, because you're going to be referring to this quite a bit this chapter. Okay? And the easier this is, now it's going to make your life a lot easier when you're trying to do confidence intervals. Okay? So the ones I picked 80%, 90%, 95%, 98%, 99%. Those are the common ones you see. Those are the common ones you see. Most of the time, it'll be something like a 95% or a 98%. Okay, so I just make a table of all of them. So 90%. And I just put the positive in there. You could just put the positive in there. You don't have to put both. 1.96, 2.3, then the last one's 2.57. Okay, so that's what we call Z critical values. Critical values. Where does the Z come from? The Z-score chart. That's what you use to figure those out, right? So you're going to see the Z a lot because that's where some of these percents came from. And those are the Z scores that go with those confidence levels. Okay? Okay, so let me get my jar of pennies. If this jar of pennies here, I'm going to ask you some questions. So I have a big jar of pennies here. So if I was to ask you to guess how many pennies are in the jar, right? That's what I want to do first. So take a look at it. If you were to guess how many, think about it for a few minutes or a few seconds, and then write down a number. How many do you think, if you were to guess? So if you were to guess, just write down a number. Write down whatever your guess is. Has everyone got a number written down?
Did you say the weight of the jar, or did you say the number?
How many pennies?
Okay.
How many? Yeah, not weight, pennies. How many? How many pennies are there? How many pennies do you think? It's all pennies. It's not trick. They're all pennies in there. There's nothing trick about it. It's just a jar with pennies in it. Okay. Okay. So you all have a number you're looking at, right? That's your guess, right? Without investigating further, that's the best you can do right now, right? You can look at it, make your best judgment, right? Okay. So my question is, what could I do for you without touching the jar? Without touching the jar, or without giving you, without letting you count or whatnot, without letting you weigh the thing, without looking at it. How could I get you to raise your confidence level in that number? So first of all, before we do that, how confident are you in your number right now? On a scale of 0 to 100%. 0 means my answer is totally wrong, I know it. 100% means I know this is the answer for a fact. How confident are you right now in that number? Talk about it with the person next to you. How confident are you? How confident are you? 0% to 100%.
If they can't be more than like 500. Yeah, that's pretty good answer.
Okay, so how many people are 0 to 10% confident that the number they have written is the correct answer? 0 to 10%. Okay, a few of you. How many are 10 to 20% confident? Few more, few more. How many are 20 to 30% confident? Anybody more than 30% confident that they have the number in front of them? You guys are pretty confident, okay. Wherever your confidence is, what can I do to raise that number, that confidence level up? What could I do?
Can you give us a range?
So keep talking about that. What about a range?
From like, let's say you say they're from 100 to 500 pennies in there. Like we can pick a number.
So giving you a range of like 100 pennies, so within 100 pennies, right? So now let's do that. I'll give you a range between 0 and 100 pennies. Or sorry. So you don't have to get the number right on, but give me within 100. So I think there are between, I don't know, 350 and 450 pennies in there, right? That's what I want you to do now. Give me that confidence. Give me that number. So before, if you said, oh, 362, now give you a range, an interval. What's that? Range. It could be within 100. Within 100. 1,000 to 1,100. 1,500 to 1,600. 0 to 100, whatever your range is. Okay? So did your confidence level go up or go down? It went up from your previous answer, right? What if I said, I'm going to make the range 500? So now, give me a range of 500. 0 to 500, 100 to 600, 1,000 to 1,500. How many of you would be about 50 to 60% confident, even more? This is the answer. Almost all of you, right? Some of you are like, you know what? I'm 90% confident the answer is true. What if I give you an even bigger range, 1,000 range? I think almost everybody would be about 90% confident, right? That's the idea of a confidence interval, right? The wider your interval got, what happened to your confidence? Went up. I'm more confident in my answer, right? I'm more confident in my answer. So how could I get you to raise your confidence level? By opening up the interval. That's what a confidence interval is, right? Confidence is how confident are you in something. And an interval is exactly what we talked about. Opening it up. How wide do you want to open it up? Okay. Sometimes it's okay to have a wide interval. Sometimes you want a narrow interval. Okay. So if I want a narrow interval, what's going to happen in my confidence level? It's going to go down, right? It's going to get decreased, right? right? It's going to decrease. So it's kind of this perfect balance, right? Okay. That's the idea of a confidence interval. How confident are we? And that's the answer. How confident am I in? Am I 90% confident, 80% confident, 70% confident? Right? Okay. So let's see. Let's skip to example number 1 right now. Let's go over confidence interval. So a confidence interval gives an interval of plausible values for a parameter based on sample data. So we take sample data. For example, we have a presidential election next year, 2024. Some of you might be 18 then or be able to vote. So in 2024, 2 people are going to run for president, right? We don't know who it is yet. There's been names out there, but we don't know yet because it's so far in advance. But polls will come out before then. You can read in the newspaper, you can read online that says this person is going to get 40% of the vote, this person's going to get 42% of the vote. Before anybody's even cast a ballot. How do they do that? Well, what they do is they take samples. They take samples of people, voters, people who can vote. They usually call them up and say, "Hi, I'm doing a poll to see who's going to be president. If you were to vote today, who would you vote for?" Okay, write it down. And then they use that data. They use that sample data of 1,000, 2,000 people, however many, and they use it to make a parameter, plausible values for the parameter. This percentage of people are going to vote for the Democrat. This percentage of people are going to vote for the Republican, right? And they come pretty close. They come pretty stinking close. It's amazing what these people can do before a vote's even cast, right? So what they're doing is they're creating a confidence interval, okay? They say, I'm this percent confident. They use things like margin of error, right? Margin of error. How off can I be? This is my answer, 40%. My margin of error is 3%. That means it could be 43 or it could be 37. That's your interval. Anytime you have a margin of error, you've created an interval, right? Plausible does not mean the same thing as possible. Plausible means that we shouldn't be surprised if any one of the values in the interval is equal to the value of the parameter. Okay? Let's see. Next page, confidence level. Confidence level. Confidence level is what you guys said. How confident are you in your number here, right? You got more confident as your interval got bigger, right? So confidence level gives the overall success rate of the method used to calculate the confidence interval. That is, in C% of all possible samples, the interval computed from the sample data will capture the true parameter. So as your interval gets bigger, your confidence goes up, but eventually it just becomes pointless. Like if I make the interval so big, you can guess how many pennies are in here, and I'll give you an interval of 5,000. Then it just becomes 0 to 5,000. There can't be more than 5,000 in here, and I know that there has to be at least one, right? So sometimes we don't want to make our interval too big. We want to make it mean something, right? Mean something. So that's the thing. How high do we make our confidence interval? It just depends. It depends. The margin of error. Margin of error is accounting for sampling variability. Not sampling error, not doing the sample not incorrectly, but just sampling variability. There's things that happen. So with the point estimate is the middle, the center. Margin of error goes in goes in 2 directions, the same value. So this right here, this margin of error is the same distance, which in this case is 0.037. Okay? It goes in the same number, same value in opposite directions to create what's called a margin of error. The margin of error of an estimate describes how far at most we expect the estimate to vary. How far is it going to vary from the true population value? Okay? That is, in a C% confidence interval, the distance between the point estimate and the true parameter will be less than the margin of error in C% of all samples. Okay, so point estimate. So we skip that part. So go back to the page right before. Point estimate. What is a point estimate? It is our statistic. What is a statistic from last chapter? What does a statistic refer to? When I say this is a statistic, what does it always refer to? The sample, right? So there's two types of things I'm going to have. Either p hat or x bar. Those are always going to be statistics, right? One is for proportions, one is for means, okay? So here we go. Identify the point estimator you would use to estimate the parameter in each of the following settings and calculate the value of the point estimate, okay? What proportion of P of, should I have parentheses around there? What proportion P of US adults would classify themselves as vegan or vegetarian, right? A Pew Research Center report surveyed 1,473 randomly selected US adults. Of these, 124 said they were either vegetarian or vegan. Okay? So a point estimate is a statistic. So which one would we use for this problem? P hat or X bar? For this guy, for this problem here. It's either going to be one or the other. Point estimate is either always P hat or X bar. For this one, which one would it be? Because it's a proportions, right? Because it's a proportion. So we're going to say P hat. What is the sample proportion in this case? So a proportion, we got to make a proportion out of that, right? We got to make a fraction or a decimal. So what number is going to go on top? 124, good. What number goes on the bottom? 1473. We use our new calculators to do that. Very first thing you're going to do, or some of you might have already. 124 divided by 1473, you get 0.084, right? 0.084. That is the point estimator, or the point estimate for this. In my sample of 1,473, about 8 or 9% of them, of those people, were either vegan or vegetarian. Does that mean everybody out of it? No, that's just out of those people, right? That's why it's a point estimate. Point estimate will always either be P hat or X bar because it refers to the sample. Okay, it only refers to the sample. All right. Let's see here. Anything else before we move on? Okay. So let's go back to the next page, bottom of the next page. Okay, so a confidence interval has 5 steps. 4 of them you've done. Actually, 4 of them you've done before. You did on the last test, right? 4 of them you did. Anytime it asks you about probability of a sampling distribution, you did that. Identify your population of interest. Either P equals, if it's P equals, it's going to be always start true proportion If it's mu equals its true mean. Okay. Like for the last problem we did. You don't have to flip back, but I'll flip back for you. So we know that the sample proportion was those 100. It was the proportion of people in the sample who are either vegetarian or vegan. We don't have this number, but who would that represent? Not how many, because I don't know how many, but who would that represent? The true proportion. There we go. It would represent the true proportion of US adults who are vegan or vegetarian. Right? That's what I mean by that population parameter. It always starts out. If it's a proportion, it always starts out true proportion. If it's a mean, it'll try out true mean. Okay? They didn't ask us that, but it's a good practice. It's good practice. It's good practice to do. Okay, true proportion of US adults who are vegan or vegetarian. I don't know that. I don't know that number. But I can write out who they are, right? I just don't know the number. Like I know the number from the sample, 0.084, and that's the proportion of people in the sample who are vegan or vegetarian. Okay? Okay. So that's number one. You've done that before. Number two is the new one, test statistic formula. Test statistic formula. We have to state which formula we're using. Okay, I'll show you the formula in a second here. Anytime you do a confidence interval, you have to state which, because there's lots of different confidence intervals. We have to state which one we're using. So how do we identify it? By using the formula. Okay, so that's why we use the formula. Conditions to meet assumptions. We've done that before. And guess what? They're exactly the same. There's 3 of them, and they're exactly the same. Okay, as last chapter. Calculations. We've done that before. You did that before in the last test. Conclusion. You've done that before. We didn't call it a conclusion. We called it a sentence to interpret, right? But conclusion is exactly what that is. Okay? All right, so let's do one problem. Let's do one problem. Then we'll be done. Okay, so the owner of a popular chain of restaurants wishes to know if completed dishes are being delivered to the customer's table within 1 minute of being completed by the chef. A random sample of 75 completed dishes found that 60 were delivered within 1 minute of completion. Find the 95% confidence interval for the true population proportion. Okay, so this is proportions. These notes focus on proportions. The next notes I give you will focus on means. Okay, so my question here is, let's pick out the stuff that's important. First thing, what is going on? Well, the owner of a restaurant wants to know how fast the food is getting from the cook, from the chef to the person, right? Because there's nothing worse than going to a restaurant for hot food and you get the food and it's cold, right? That makes the restaurant look bad. So he wants to know what percent are getting within 1 minute. They're not sitting there too long. From 1 minute, between 1 minute of the chef being done with it to it getting to the customer's table. Okay? So he took a random sample and found that out of 75 completed dishes, 60 of them were indeed there within a minute. He wants to find a confidence interval for the true answer. So his restaurants have served more than 75 dishes. They've probably served thousands, if not more. He took a sample of 75 and he's going to use that to figure out what the true answer is. Okay, that's what we're going to do. We're going to create an interval. And I'm going to create that interval, and I want to be 95% confident that the true answer is within that interval. That's what he wants to do. Okay? So the first thing, it's proportions, right? We know it's proportions because you see proportions all over the place. Right there. 75 out of 60, or 60 out of 75. So 60 out of 75 is a proportion. Which is 0.0, 0.8. What symbol goes with that guy? It's either going to be p hat or x bar. And since this one is proportions, it's going to be p hat. The sample proportion. Okay? N, you see n down there? We're going to need n. So what is n equal to? 75. 75 were total in the sample. A random sample of 75. Okay? Okay, so population parameter. The true proportion, so this number here is the sample proportion. Who would the true proportion represent? The true proportion of all dishes delivered within 1 minute of completion. Okay, we don't have that number. That's what I'm trying to do. I'm trying to create a confidence interval to figure out what that number is. Okay. Point 1 point. Next one, test statistic formula. This is the formula we use. It's not all of it. Let me show you the formula. The formula is this part in yellow. And tell me if any of this formula looks familiar. Yeah, you used this one last chapter, right? And what about this formula is nice? It's on our, we don't have to memorize it, right? The ugly part of this formula is this guy right here. We don't have to memorize that. It's on our sheets. This part right here is not hard. P hat, we already know what P hat is. We already got that done. Done. Z critical. Where have I heard that from? Critical, Z critical. Where have I heard that from? From the table. What confidence interval, what confidence level did we need? So guess what? We're going to use that Z critical. So it's not even calculating. It's just looking, right? Either one of them, it wasn't really big calculations. Okay? But the reason we have to write the formula in is because it identifies. This is a 1 proportion Z interval. 1 proportion means I only have 1 sample. I don't have 2 samples. I only got 1 sample. That's why I put 1. It's proportions. We're using Z, and it's an interval. So that's why you have 1 proportion Z interval. Okay? So down here, this just explains the parts of it, right? So everything after the plus or minus is what we call the margin of error. Or what we call the margin of error. This is all the margin of error. Okay? The margin of error consists of the Z critical times the standard error or the standard deviation, right? Like we talked about, right? Those are the parts of it. Okay? This part right here in pink is actually on the back of your formula sheet. It's actually on the back of your formula sheet, that part right there, just like that. not the yellow, the pink, the fuchsia color. It might help, it might not help, but that's what it was. That's what it is. Okay, it's the statistic, p hat or x bar, plus or minus the critical value, times the standard deviation of the statistic, which is also on your sheet. So I tell students are like, well, the whole thing's not on there. I'm like, yeah, but if you could pick one part, which part of it would you hope to be on your sheet? That part right there. That's the part I don't want to have to memorize, and you don't have to. Okay? All right. So next thing, conditions, assumptions. Let's do conditions, assumptions. This is probably the last thing. We probably won't finish this today. So let's do conditions for assumption and check. Just like last chapter. SRS. We have a sample of 75. Was that sample randomly generated or randomly come up with? Yes, it says stated. 10% condition. N is less than or equal to 10% of big N. Okay, we know little n. We know little n. It's 75. 10%. We don't know a number for big N. But if little n is 75, who is big N going to be? Or who is it going to represent?
All the completed dishes.
All completed dishes. Right? All completed dishes. That number would need to be at least 750. We don't know that for sure, but we just write the number. We just write the value in there. Okay? So for our numbers to be reliable, the owner should know that all completed dishes need to be at least 750. And if it's a popular chain restaurant, I mean, 750 dishes is not that much. You'll get through that in a week. Okay? Last one. Is shape approximately normal? Number 3 is the one that varies from means to proportions. So be careful with that one. For this guy here, remember, it's proportions. So we're going to use this guy right here. N times p greater than or equal to 10. N times 1 minus p greater than or equal to 10. We don't use the central limit theorem for proportions. That's only for means. Okay? N is 75. P. Do I have P? I know what it is, right? The true proportion of dishes served at the restaurants. I know what it, but do I have a number for P? No, I don't. So what do I use? I need a number. Use p hat. Yeah, use p hat. If needed, use p hat. It's better than nothing. Is it perfect? Is it ideal? Nope, but we don't live in an ideal world. Okay, last thing we do. This is 60. 60 is definitely bigger than 10. This is 15. 15 is definitely bigger than 10, so we're good there. Okay, so when we come in tomorrow, first thing we'll do is we'll do the last two, calculations and conclusion. Okay.